And welcome back, AP Econ students. Time for a free response question from an old AP exam. Today we are looking at the AP Micro exam from the year 2015, and we'll be looking at all three parts to this question. Now, the likelihood is quite high that question number one on the micro exam is going to be giving you a scenario where you have to address a market type. Now, when I say market type, in general, there's four market types if you recall that unit, but there was really two in general. There was the perfect competition and the imperfect. And so as I go through this, some things are going to come up as far as review. And so if you recall, when we had the perfect competition, that was where you first learned about Mr. Darp. And if we say long-run equilibrium, we would have our ATC right here and our marginal cost curve coming through there. And if you recall, you had your tattoo where MR equals MC, but this would be long-run equilibrium. And the main thing that distinguished long-run equilibrium, perfect competition, was that your demand curve was equal to your marginal revenue curve. And that was perfectly elastic. And these are markets where you have thousands of small firms, and the market actually determines the price. And that was to be contrasted with imperfect competition, which there will be those where you could ask the exact same question, but just tweak what the market type is. And so it could be one of the three imperfects. And if you remember, we would chopstick it from above, and we would have our demand curve and our marginal revenue curve. And then we would put our average total cost curve would come through like that. And we would have marginal revenue and demand, which was still price. And then we would have our ATC come through, our marginal cost curve come through here. And it was much more complicated as far as reading this graph because there are points of intersection, and we'll go over that more later. But we had to, the chances that the question number one is going to be one of these two market types is probably 95%. Then it will be, they're either in long-run equilibrium, they're making a profit, or they're losing money. And so you want to be able to say, I know what a perfect competition looks like in long-run equilibrium, making money or losing money. I can do all three of those. And I could do the same thing with an imperfect competition. Now, if you recall, imperfect competitions, they all look basically the same. You would have to have additional information to know, in fact, this graph right here. You couldn't tell whether this was a monopoly, an oligopoly, or monopolistic competition. You would need more information because their graphs all look the same. And so that's just something to come up. Now, this particular question kicks off with perfect competition. And the other thing that separates perfect competition from imperfect is we frequently have side-by-side graphs that contrast a firm with the marketplace. And the market is how we figure out Mr. Darp, if you recall that. And we don't do the side-by-side models over here. We talk about it, but we don't do the side-by-side. So that's just kind of to prep you for the question. It's going to be a market type that's in some sort of condition. We're going to have to be able to draw it, have our points of intersection, and address the questions. Okay? So be prepared. That's probably going to be question number one. And it'll be long and involved and probably have 10 questions applied to the scenario. So let's read and see what we have here. So it says, a typical profit maximizing firm in a perfectly competitive, constant cost industry is earning economic profit. So it is earning economic profit. Well, just for the sake of review, I actually want to draw the three versions of perfect competition to refresh your memory. The one I just had written here was when Mr. Darp was here, and we had our ATC and our marginal cost curve all intersecting at the same place. And that was long-run equilibrium, because if you recall, the reason you're in long-run equilibrium is if you're losing money, firms exit. If you're making money, firms enter. So in the long run, we're breaking even, making normal profit, which is still a good thing. Now, there's two scenarios or two ways to look at when you're, we'll move up here, that we're making money. Two things could have happened to make money. Either Mr. Darp was higher, or you could say the ATC was lower, however you want to say it. And so what I'm going to do is actually draw my ATC and my marginal cost curve. And I'm just going to make Mr. Darp, I'm going to elevate him because Mr. Darp, the MR, is marginal revenue. I'm going to say, well, what if actually Mr. Darp was high. Okay. Now, just to come back to here, if you remember, your tattoo, the most important thing in micro is MR equals MC. That's where we maximize profit. So in this one right here, where MR equaled MC was right here, and this rectangle down here, for this example, this box right here, that represents our total revenue. That's how much money came in, but it's also equal to our total cost. They're both the same. Because MR equals MC gave us this quantity, so I'm going to put this as our quantity of profit maximization. But, as it turned out, our costs and our revenue were the same price. We were in long-run equilibrium, making normal profit. This is good. But when we're making money, Mr. Darp is high, and we're going to contrast that with this one, where MR equals MC would be right here. That is still going to be our profit maximizing, so I'm going to have a Q sub PM. And again, the assumption is we know our vertical axis is price or cost, and our horizontal is going to be quantity. Okay? Well, look closely at this one. If this is our profit maximizing quantity, this big rectangle that I just have, that's total revenue. So this entire thing here, that whole rectangle there, that would be our total revenue, which is pretty big. Now, the total revenue is going to be made up of two things. It's going to be made up of costs and profit. So, if you look at this one, if we go to where our profit maximization quantity, where it hits our cost curve, what it's going to do is break the total revenue up into two separate rectangles. There's going to be this one here, and that would actually just be our profit. And the one below, we'll shift to red here just to distinguish them. And so this one down here, this would be our total costs. Okay? So for these examples, it's kind of weird how you bring in a whole lot of revenue, but most of it went to costs. So your total revenue in this example is going to equal your profit box up at the top, and then we would add to it our total costs. Okay? And it's because Mr. Darp was high, or if you prefer, ATC dropped. But in either case, you should be able to look at these quickly and determine, is this a profit situation or a loss situation? And on this one, you're making money, firms would enter and pull Mr. Darp back down. Now, the third scenario you're going to have is what happens if Mr. Darp is low, and that's why for these it's good to just draw your marginal cost curve and your ATC. You just say, well, Mr. Darp is low, it's going to be lower than this here, so I'm going to draw him way down here. And low Mr. Darp is below our ATC, but MR equals MC is still right here. And so that's important that this becomes my profit maximization, but it's also loss minimizing. So I'm there, and then my costs would be right here. Okay? And so what you're going to see here is we'll use the same crosshatch pattern. Right here, what this turns out to be, this is how much money is coming in. So don't go by the color, they mean different things in different diagrams. But there's how much revenue is coming in. So there's your total revenue right there. And up here, we'll do this little sketch right here. This in blue, this is your loss. And the reason we're losing money is our costs are higher than our revenue. We're bringing in less money than it's costing us. So for this one works a little bit different. On this one, we would say, well, our total costs would be equaling our total revenue in this situation, plus the losses. Okay? So let's look at the two scenarios here. Total revenue equals total costs. We're making money, and our total revenue is equaling our costs plus our profit. We're making extra money. That's kind of cool. But then down here, our total revenue is less than our total costs. So total costs would include revenue plus the amount we lost. Okay? So that would be the largest. All right? So in this situation, the question is saying it's this one up here, top one. So I just wanted to review those. Don't forget there's also an issue about your average variable cost curve and the shutdown price, but we'll save that for later. Okay? So let's look at the question. It says, In a typical profit maximizing, making profit once, let's look at this one right here. Is the market price greater than or equal to the firm's price? Well, remember, these are the graphs for the individual firms. The market is to the left, and I had that drawn before. So if I did this one right here, this would be the market that created Mr. DARP. Okay, so there'd be a supply and demand curve, and it's at an angle here, but pretend that was equilibrium that kicked out Mr. DARP. So the question says, is the market price, this is the market, this is the firm, is the market price greater than, less than, or equal to the firm's price? Explain. Well, the way you get Mr. DARP is from the market, so they're actually equal. So for question A, I would say equal. And the verbiage we can use here for explain, you just say, well, they're equal. The firm, if you remember this lingo, the firm is a price taker. You take the price from the market, and that's a good enough explanation. Okay? Let's move on to part B. Part B says, draw correctly labeled side-by-side graphs for both the market and a firm showing each of the following. So basically what they're wanting is to have a very nice picture of this right here. And so this is where you want to take your time and go ahead and do that. So I'll redraw this, and it's not bad to redraw these as you're practicing, because you want that volume of practice of having drawn these. So we will draw the marketplace, and you can use a straight edge if you've got one, and we will draw the supply curve of the marketplace, and here is the demand curve for the marketplace. This is the quantity, and this is the price. Okay, and then side by side it says, so here is going to be the firm. Okay, and I'm actually going to label this the market. Probably should have drawn it just a little bit lower, but here's the market, and this will be the firm. Okay, and so what I'm going to do is I'm going to draw Mr. DARP first, because I want that picture to line up nicely. Okay, and then the problem says that we have to draw a graph in which you're making money. Okay, so if we're making money, I'm going to make Mr. DARP, he's in here, so I'm going to make the ATC lower, and then bring in my marginal cost curve. So there is my ATC, and my marginal cost curve intersects at the minimum. And little things from earlier in the year, if you remember, it's better if you give your marginal cost curve a little angle, like this one is. If you make it more vertical, your graph gets a little hard to read. Okay, and so we have this all labeled, and now we have, or not labeled, but drawn, and now we have to label the specifics of what they're telling us in the question. So for part B, number 1 says the market price and quantity labeled as P sub M and Q sub M. So this is the market, so I'm going to dot down here, and I'm going to just put a Q sub M for market. And over here, I'm going to put a price sub M. Okay? That one's done. Part 2, the firm's quantity labeled as Q sub F. Well, the firm over here, and this is your MR equals MC. Very important that you guys get it. Well, there's MR, there's MC. This is our quantity right there. And they want to see that you know MR equals MC. And I'm going to put a Q, and it says sub F, quantity for the firm. Okay? The firm's average revenue curve. Well, that's right here, which is a part of Mr. DARP, and it's fine if you have Mr. DARP here. Mr. DARP's a fairly common mnemonic that gets used, so it's okay to have that there. And the firm's average total cost curve labeled, we have that. And the area representing the total cost completely shaded. Now, the part that's a little bit, you got to be careful there, is they oftentimes want you to shade the profit or the loss box, so it's weird that it's the total cost. So if you look over here, if you remember, the total cost in this one was the red area here. So I need to go to where I'm hitting my cost curve, and I want to be careful here. Make a dotted line over. If you remember from earlier in the year, the vertex of the cost curve should not be in the box. So I'm going to shade this completely, and this will be my costs. And I'm making money because my revenue is higher than my costs. Okay, so it says shade completely, so I'll just crosshatch that. Okay? And part B is completed. Now part C. If one firm in the market were to raise its price, what will happen, and explain? Now this is testing you on number of firms. So if you remember, if I'm in perfect competition, I want you to pretend you go to the farmer's market and there are 100 farmers selling avocados, all $1 each, and they're all identical quality, they look great. And you go there, and 99 tables are selling them for $1, and there's one guy selling them for $1.50. And you're like, why are you selling these for more? The table right next to you is their $1. He's not going to sell any. You have no influence over the price, the market does. So when you get a renegade person that decides to put a higher price, their total revenue goes to zero because there's no reason you would buy from them. There's no secrets there, you just don't. So if one firm in the market raises price, what will happen to its total revenue? You're going to say total revenue, or TR, goes to zero. Because everyone will buy the cheaper product. And once again, the firm is a price taker, and if you don't take the price, not good for you. Okay, and there's your explanation. Part D. Now suppose the market is in long-run equilibrium. Suppose that's true. The government gives a lump sum subsidy to each firm producing in the industry. Indicate whether each of the following will increase, decrease, or remain the same. Now, there's another good reason why I drew these here, because it'll be nice to answer this next question. So let's focus on this graph right here. You're in long-run equilibrium, okay? And you don't have to draw it, but you might want to draw it just off to the side so that you have it ready to look at. And so, not required to be drawn, but we have it here and we can use our picture. So suppose we're in long-run equilibrium, everything's good. The government gives a lump sum subsidy to each firm producing in the industry. Indicate whether each of the following will increase, decrease, or remain the same. The firm's quantity in the short run. Well, what I'm going to do on this graph, everyone, just to get this will be easier for everybody to see, is I'm going to draw my lump sum subsidy. Now, they're making one of the concepts you got to make sure you have down is lump sum versus per unit subsidies. Okay, and so I'll go ahead and write this down here. Per unit versus lump sum. They love asking this question. Okay. Now, when you have a lump sum, this is going to either, if it's a subsidy, by the way, your lump sum subsidy is going to lower your ATC. Okay. Your per unit subsidy is going to increase your supply curve. Okay, and if you guys think about it, think about the very first things you learned in supply and demand: government actions, taxes or subsidies, shift the supply curve. Well, if you remember, your marginal cost curve is actually your supply curve, and so I'm actually going to make that, I'm going to say what it does is it increases your marginal cost curve, which is equal to your supply curve, if it's per unit. So that's what they're testing you on in this question. Are you going to move the right curve? So let's go to here. This is what's going on, and all of a sudden, boom, the government likes your industry and says, hey, here's a lump sum subsidy to help you with your production costs. So what's going to happen is my ATC is going to lower. So I'm going to pick a point right here, and I'm going to draw a new ATC. Okay, now keep in mind, my ATC just lowered. My marginal cost curve did not. So here's my new ATC. I'll call it ATC prime because of this lump sum subsidy. So that's pretty cool. So let's see what wound up happening, okay? Now, my marginal cost curve, now remember, before I was breaking even, but now my costs are lower. So what's going to happen is my quantity is going to go up, and I'm going to hit my cost curve and go over. Look at the adjustment that happens because of this. And I think I'll do this in blue here to contrast it. Instead of saying my total revenue equals my total costs, now look how low my costs are. My MR equals MC amount didn't change, and now I go up to here and I go this way. And now I'm like, hey, check out my total costs. They're just this blue area now. This is pretty cool. And look at that major profit I'm making. Okay, so it's not this anymore. Now, my total revenue is, the total revenue that's coming in here is going to be more like this one up here. And so now I would say, oh, my total revenue is going to equal my total cost plus the profit now. Okay? So, let's go back to the question. It says, if this happens, okay, so now we have this new graph. And so here's our costs now. And this little region up here is our profit, okay? Make sure everybody gets that here. So with my new adjustment here, this is now profit. Okay, and this down here is now cost. Okay, so it says, what happens to the firm's quantity in the short run? Well, here's what they're testing you on. If your ATC moves, did Mr. DARP and marginal cost, did that change? And the answer is no. In fact, they're still intersecting in the same place. So for part D right here, for D1 I should say, it says, what happens to the firm quantity in the short run? No change. And the reason that there is no change, you say MR equals MC is the same. Is the same as before the subsidy. Okay, got that. And now part 2 says, what happens to the market price and quantity in the long run? So now if this is what's going on, what's happening in the long run? Well, in the long run, since profit is being made, firms will enter. So if firms enter, what does that do to Mr. DARP? So the first thing you're going to do, what's going to happen to the market price and quantity in the long run? Well, let's go to here to firms enter. Let's just state what's going to happen here. Okay? Now to fully understand this one, I know some of you guys can visualize this. I want to go up to this graph right here. And I'm going to tweak this one a little bit more. I want to go to a profit graph that I don't have as much clutter on here. And let's just see what happens when we do that. So I'm actually going to, I just want to draw this a little bit better. Okay, and so let's see if we can get that here. So that was about where Mr. DARP was. So all I want to do is draw my supply and demand curves. Okay, so let's pretend this is what was going on in the firm. So here was the market price that was creating Mr. DARP, okay? And money's being made. Okay, now if money is being made, entrepreneurs that are seeking profit come in here. So if money is being made, there's going to be an increase in supply because firms will enter. So I want you guys to look what happens to Mr. DARP. When firms enter, here's my new market price, which is going to pull Mr. DARP back down to here to long-run equilibrium. That's why in the long run, you're always in long-run equilibrium, because profits mean firms enter and they pull down Mr. DARP. So Mr. DARP would be down. So, but the question says, what happens to the market price? Let's answer that one first. Here's the market. That's this guy on the left, okay? When firms enter, what does it do to market price? It pulls it down because of an increase in supply. Firms enter. So there's a decrease in market price. Okay, and let's see what happens to market quantity. All right, you guys, this is where we were, okay? But this increase, we increased our quantity, but the price went down. Okay, so this new price, our price dropped, but our quantity increased. So we had a decrease in market price, increase in market quantity. And I'm just going to get that out of the way for now. Market quantity. Okay. Now explain. The firms enter is kind of your explanation. If you want, I could have written a little more of a sentence there. Firms enter seeking profit. And that implies everything that happened. Firms enter seeking profit, which leads to this graph, and that would be fine. In fact, you could put that graph with it if you want. Okay? So, we took, on this one, there was a little extra notes here off to the side and a little bit of review, but if you knew what you were doing, you jumped right in. This is like, 5 to 10 minute question. 10 minute, even if you make nice and neat graphs. So make sure you don't get distracted by how many notes I'm doing. Just jumping in here to knock this out pretty quick, so like especially if you've reviewed and you're in good shape. This is like a 5 to 10 minute question. And it's just knowing your market types and all of this stuff, okay? So there is question number 1, the longest of the 3. And now we will switch here to question number 2. All right, time for question number 2. So on this one, it's pretty obvious, jumps right out at you. You have a payoff matrix. So if you know how to do a payoff matrix, these are actually very easy questions. But if you don't, it's like taking a quiz in a book you didn't read. You're totally lost. So we'll review a little bit on how these payoff matrices work and how to read them. And so these have to do with, if you recall, the prisoner's dilemma, and specifically an oligopoly, or more precisely a duopoly, where knowing what the other business person's doing really matters. So what I'm going to do, I have the graph here enlarged so we can read a little easier, and I'm just going to highlight it just to review. Whichever company is to the left, all of their values are on the left side of each box, and whoever's on top is on the right side. So these two companies, sandwich companies, are trying to figure out how to price their items for profit maximizing. So the numbers you see in the matrix are how much profit they would make if they priced their sandwiches or food accordingly and with what the other person did. So, for example, if both companies charge high prices, this would be their profit: breadbasket 105, quick lunch 110. If they both decided to price low, 75 and 70. So logic tells you, well, if you're charging higher prices, should you be making more? Not necessarily. It depends on cost. Depends how much the other company is taking business away from you, because if you price high and the other company prices low, maybe they're going to take all your customers. So that's why this working together is so important. But just to make it easier to read, what I want to do here is I'm just going to highlight breadbasket with my highlighter here. And I'll say, well, breadbasket are the companies that are, or the numbers that are yellow. So it just makes it a little quicker here, and you keep from getting confused. Okay. And quick lunch will be just the, we'll go ahead and underline those in red, and that'll make it a little easier. And so these guys are these prices. All right. So normally when you get this kind of question, I recommend don't even read this stuff. Just figure out who has a dominant strategy, go through that whole process, get all your results, and then we'll answer it. Because reading the whole payoff matrix winds up answering all the questions they're going to ask you anyway. So let's go ahead and go through this, and we're going to figure out dominant strategy. Now, a review on dominant strategy: if you want to see if a company has a dominant strategy, you force the other company to make a decision. So what we're going to do first, we're going to see, does Quick Lunch have a dominant strategy? Okay, so that's my question. Hence, I'm going to force breadbasket into doing something. So what I'm going to do here, I'm going to say, so the question is, does Quick Lunch have a dominant strategy? Okay, so this is the question we're answering. Okay, so that's my question mark. Quick Lunch dominant strategy? Well, I don't know. Let's see what happens when breadbasket does something. So we're going to force breadbasket to do something. We're going to force breadbasket to go low. Okay, so if breadbasket goes to the low price, you just have to figure out what's better for Quick Lunch. So if breadbasket goes low, what's better for Quick Lunch? Making 80 bucks or 70? Everybody would say 80 bucks. So you would price high. So when breadbasket goes low, Quick Lunch is going to go high. I'll just put an arrow up for high. Okay. Now let's force breadbasket to go high. Let's see what happens. So if breadbasket goes high prices, what's better for Quick Lunch? 110 or 130? Well, 130 is better. So since 130 is better, Quick Lunch would go low. Okay. So looks like no dominant strategy, because it depends on what's going on. One time a high price is better for them, another type is low. So there is no dominant strategy. So I'm going to say no DS. Okay. Now just so I don't lose anybody on this one, when I force breadbasket to go low, the reason that Quick Lunch went high, I just want to write this here in case you're reading, going over this later. It's because 80 is better than 70, so that's why they went high. And why they went low on the last one, when breadbasket went high, that's because 130 was better than 110. Okay, so that's why they made those decisions. So no dominant strategy for Quick Lunch. So no DS for QL. Okay, got it. Now let's just do the same thing over here. So does Breadbasket, do they have a dominant strategy? That's our question. All right, well, let's force Quick Lunch to do something. So let's make Quick Lunch go low. Let's see what happens. All right, so let's read this now. Quick Lunch, we force them to go low. All right, so now we read Breadbasket. What's better for Breadbasket, 75 or 40? 75 is better, so Breadbasket would go low. So Breadbasket goes low, and our reason is 75 is better than 40. All right, now let's force Quick Lunch to go high. Okay, so now Quick Lunch chooses the high prices. What's better for Breadbasket, 120 or 105? 120. So they would go low again, because 120 is better than 105. So as it turns out, Breadbasket has a dominant strategy. Okay, so Breadbasket, dominant strategy is to go low. Well, now that we know that, we know that Breadbasket's going to go low the whole time. So if Breadbasket is going to go low, I'm going to grab this here in pencil, we can actually circle that, and we can say, well, if Breadbasket is going to go low, let's go ahead and circle this one. They're going to go low. Okay, that will happen. Well, if they're going to go low, now we just see what's better for Quick Lunch. Well, we already figured out when Breadbasket went low. Over here, Quick Lunch, 80 was better than 70. They were going to go high. So this is the situation. This is the one that's going to happen right here. Okay, so I'm just going to circle this one and say this is actually the Nash equilibrium. This is what's going to happen. Okay, so we've already figured that out. Okay, now see than likely we just answered every question they're going to ask. That was just reading the matrix and figuring out what's going to happen. Okay, so now let's go ahead and do that. We'll see if we have enough room to leave this here. All right, so let's go over here to Part A. So Part A says, or let's read the question now. Breadbasket and Quick Lunch are the only two sandwich shops serving a small town. Each shop can choose to set a high price or a low price for sandwiches. The payoff matrix to the right here shows the daily profits for each combination of prices that the two shops could choose. The first entry shows Breadbasket's profits, and the second shows Quick Lunch's. Assume that both shops know the information shown in the matrix. Okay, so question A. Does each shop have a dominant strategy to set a high price, dominant strategy to a low price, or no? Well, we already figured that out. We don't have to explain. We're just going to answer them. So the first one, does Breadbasket have a dominant strategy? We will say yes. They do have a dominant strategy. Breadbasket goes low. Okay. Question 2, does Quick Lunch have a dominant strategy? No, they do not. Okay. Next one. B. If the two shops do not cooperate on setting prices, what will the profit be for each shop? Well, they don't cooperate. They're just reading each other, and this is what happens, our Nash equilibrium. So Breadbasket's profits is the yellow one. So that is going to be for 1, they're going to make $120. And for Quick Lunch makes the $80. Okay. Then Part C says, the town government is concerned food prices are too high, so it decides to give a daily subsidy of $20 to a shop that chooses to set lower prices for its food items. Redraw the payoff matrix under the government's subsidy system. And then they're going to ask us these questions again. So I'm going to come over here. Let's see if we can do C right here. We'll draw a new payoff matrix. So I'm just going to draw the numbers here. Okay, and again, this was the high price, this was the low. High, low, and over here was Breadbasket, and up top here, this was Quick Lunch. So you get a $20 subsidy if you charge a low price for your sandwiches. Well, that means if we look up here, anytime you had a low price, you get a bump in your profits. Now, make sure you understand, you're getting a subsidy. You're not you're charging your low price for your sandwiches, but you're just getting rewarded by the government giving you the subsidy. It doesn't affect your prices anymore, and you're just getting a bump in your increase in profits here. So the nice thing is you can very quickly say, well, this was where they were both high, so there's no change in these. This is still 105 and this is 110. No subsidy if you charge high prices. Now if they both charge low, both numbers are going to change here. This one's going to go up to $95 and this is going to go up to $90. Okay, those got a bump. Now you just got to be careful. Make sure in the next two only one number is going to change, but you just got to be careful you change the correct one. It's easy to make a silly mistake here. So let's go to this one first. This is Breadbasket has the low price. Quick Lunch has the high one. So the lower price is the one that would be right here. So that's the 120. So we're going to add $20 to that to get 140. This is Quick Lunch's high price. There's no change. It's still $80. Okay, make sure you get that down. And then we'll go over to this one. It's going to flip-flop. Now on this one, the low price is Quick Lunch's. That's the red underline. So 130 will increase to 150. Okay, but Breadbasket's price at $40, that's still the high one. It's not actually the price, it's the profit they would make. So here's our new payoff matrix, and then we basically have to do the same thing we did before. So let's go through this with our reading this thing, and I'm going to, I'll just put a red square around all the ones that went with, a red rectangle, around all the ones that go with Quick Lunch, make this a little easier to read, and let's see, hopefully you can read this. I'll put blue, and I'll just circle all the ones that are here. Hopefully that'll make it a little easier to read. Okay. Alright, so let's do what we did before. So let's see if anyone has a dominant strategy. Alright, so we'll do just what we did up here. Okay, so let's force Breadbasket to go low, and let's see what happens. If Breadbasket goes low, what's better for Quick Lunch, 80 or 90? Well, they're going to go low. So in this one, Quick Lunch will go low, and the reason is 90 is better than 80. Okay, so what if Breadbasket goes high? Breadbasket goes high, Quick Lunch is still going to go low because 150 is better than 110. So all of a sudden, Quick Lunch has a dominant strategy. They didn't up here, but they do now. Okay, so 150 is better than 110. So I'm going to say Quick Lunch has a dominant strategy, which is to go low. Okay, let's try this one. Now we're going to force Quick Lunch to go low. Let's see what happens. So Quick Lunch chooses low prices. What's better for Breadbasket? 95 is better than 40, so they should go low. So Breadbasket will go low. 95 is better than 40. Now what happens if Quick Lunch goes high? If Quick Lunch chooses the high prices, Breadbasket is looking at 140 versus 105. It's still going low. And so we could say, well, then 140 is better than 105. So it looks like Breadbasket has a dominant strategy again, and it is to go low. So if they both go low, it looks like here's where this is what's going to happen. They both go low. So now let's read the last two questions on Part C. So Part C says, using your redrawn payoff matrix, answer the following. Would Quick Lunch choose to set high prices or low? Explain using specific values from your redrawn matrix. And you would say, Quick Lunch is going to go low. And the reason they're going to go low is 150 is better than 110, and 90 is better than 80. Okay, so I'll put that right here. So I'm going to say Quick Lunch chooses low. And I'm going to say the reason they're choosing low is that 150 is greater than 110, and 90 is greater than 80. That's why they're going to go low. All right, then, would the profits for Breadbasket increase, decrease, or stay the same? Explain comparing your answer to the last one. So let's go back up to our other one. Remember, this is what did happen originally. Breadbasket was making 120. Well, now down here, Breadbasket is making 95. So they're actually making less money. It went from 120 to 195. Okay? So would the profits for breadbasket increase, decrease, or stay the same? So this was 1. So here is 2, and we would say decrease. Okay? They would decrease and explain. They would decrease from $120 to $95. And that's a good enough explanation, okay? Because you're using specific values, all right? So there is question number 2, a payoff matrix. And again, if you're familiar with your payoff matrices and you know how to read them, you can cruise through this one pretty quick, but I'm explaining, obviously, and going through. So usually that's another like 5 to 10 minute question. And just make sure you're being methodical. Use colors, highlighters, whatever you need to make sure you don't make careless errors. Those are usually the only kind made in a payoff matrix. It's something silly, and you just made a careless error, and unfortunately you don't catch it until you find out your score was low, and if you get your test back you can see it, but otherwise you have no idea. So that is question number 2. Let's move on now to number 3. Okay, question 3 has a graph of a pretty typical supply and demand situation, and then is just going to ask questions regarding surpluses and elasticity and that type of thing. So it says the graph below shows the market for widgets. The government's considering intervening in this market. So you can see the demand curve, the supply curve, and we have a point of equilibrium at a price of $20 and a quantity of 20. And you can tell just by the steepness, it's a little bit inelastic on the demand. Supply looks kind of unit elastic, pretty close. In fact, we're going to, intersecting at 10 and 10, 20 and 20. So that's looking unit elastic. Demand's a little steeper. So let's see what we have here. So letter A says, calculate the total producer surplus at the market equilibrium price and quantity. Okay, so just a quick review here. When you have your supply and demand curves, if you recall, from earlier in the year, we divide equilibrium into consumer surplus and producer surplus. So they're basically just asking us what is the area of this lower triangle. So it's we'll keep track of these down here. So it's just a 1/2 the base times the height. So this distance here is 20. This is 20, so it's 1/2. 1/2 times 20 times 20. So we're going to get $200 is the amount of the producer surplus, lower triangle right here. Okay? Then, let's look at part B. Part B says, if the government imposes a price floor at $16, is there a shortage, surplus, or neither? Well, I'm going to redraw this over here so we can look at this. We're currently looking at this situation right here, where we have equilibrium is at $20. Okay? So if you recall, it's saying to put in a price floor at 16. Well, that's going to be down here. Well, if we put in a price floor that's at $16, remember the rule. The rule is if a floor looks like a floor, it has no effect. A floor would have to look like a ceiling. So what's going to happen is as the price drops, it's going to stop here at 20. This price floor below equilibrium, they have no effect. And so our answer is going to be neither. And then explaining, you can just say price floors below equilibrium have no effect. Put that here. Have no effect. Okay? And then we'll look at C. C says if instead the government imposes a $12, so I'll actually just even erase this and I'll make it a 12. So what happens if they put in a price ceiling? Well, when a ceiling looks like a floor, it definitely has an impact. And so this would be a situation where the government steps in and says, your product is too expensive. Therefore, we're going to put in a price ceiling that does not allow the price to rise. It hits the ceiling. It doesn't allow it to rise past this amount. And so if we look at our typical curves here, that means your quantity supplied is far less than your quantity demanded. If your quantity supplied is less than your quantity demanded at this low price, you're going to have a shortage. Okay, so if we put this dynamic on here, you can just imagine this right here at 12, and we're going to have our quantity demanded at 12 is actually a quantity of 12, our quantity supplied is 12, and the quantity demanded at 12 would actually be 24. And so C says instead, shortage, surplus, or neither, and we would say shortage. And our explanation would be the quantity supplied is greater than the quantity demanded. And whenever that's the case, you're going to have a shortage. Okay? Let's move on to part D. It says, if instead the government restricts the market output to 10 units, calculate the deadweight loss. So this is a little bit of an unusual type of restriction. This doesn't come up too often in questions, but instead of limiting things with ceilings and floors, the government sets in and says you're not allowed to make beyond a certain amount. So they actually insert a boundary on the quantity axis. So when that happens, you make a vertical line wherever that quantity would be. So I'm going to do that on this drawing right here. If the government steps in and says you're restricted beyond making a certain amount right here, so this is the government restriction, then you can see equilibrium is to the right of it. And so if the government comes in here, you can see that at that quantity, the demand is much higher than the supply. So we should keep making more, but we're not allowed to. Therefore, if we're restricted, this is where our deadweight loss triangle comes in, because we're not allowed to go there. So what would look like a normal deadweight loss triangle in like a tax situation, where we would make our box, that type of a thing, it's the same idea. So if you go in here, and we put in our restriction here at 10 units, in our picture, you wind up seeing this right here. We would say, well, looks like this would be our deadweight loss. It's going to be this triangle right here. Similar to this picture here, and we would just have to have our dimensions. So I'm going to move D right here. And our dimensions, it's going to be a triangle again, so it's 1/2 the base here. We're going from 40 down to 10, so that's going to be 30. And then the height here is going from 10 to 20, so that's 10. So you would wind up with $150 as your deadweight loss. Okay. Now part E, we have two parts here. So assume the price decreases from $20 to $10. So we have a price that is dropping. The price drops $8 from 20 to 12. Calculate the price elasticity of demand. Okay, well, let's do a little review here of elasticity from the first place. And in general, we have 5 different types of elasticity. If we go with demand, we have perfectly inelastic demand. We have relatively inelastic demand. We have unit elastic demand. We have relatively elastic, and then we have perfectly elastic. And so if you remember, elasticity has to do with how responsive are you to a price change. So here's the two extremes. Right here, when you are perfectly inelastic, your quantity does not change based upon a price change. So let me expand upon this and make it a little larger. If this was on an axis right here, and let's say this was a quantity of 10, and this right here was, I'll call this $5, and then I'm going to raise it to $20, okay? And so at the price of $5, you buy 10 units. The price rises to 20, you still buy 20 units. Or you still buy 10 units at 20. Regardless of the price, the amount you buy doesn't change. So usually the classic example for this would be like drug addiction or an insulin, a diabetic that has to have this. It's a life or death issue. So regardless of the price, the amount you buy doesn't change. Well, let's look at this as far as an elasticity calculation. Now, if you recall the price elasticity of demand formula, it's going to be your percentage change in quantity over percentage change in price. Now, there's a couple different ways to manipulate this formula. We use the midpoint formula in ours, but it's the percentage change. And so when you use the midpoint method, if you recall, we had a fraction above and fraction below. So by the midpoint method, we have the difference divided by their average. So on this one, if we just said the quantity change, well, from this point to this point, your average of 10 and 10 would still be 10, but you bought 10 here, you bought 10 here, your difference would be 0. Now your percentage change in price, you went from 5 to 20, well that was 15. And your average price here is going to be $12.50. Well, the denominator doesn't even matter, because look at what happens. You wind up with 0 over this fraction right here. And again, it doesn't matter what it is here, you get 0. So the elasticity coefficient for perfectly inelastic is 0. Okay? Now, if we go to the exact opposite extreme over here with something that's perfectly elastic, you're super sensitive to a price change. This is kind of theoretical, because it would be the reciprocal of this, and you would have 0 on the bottom, and the elasticity coefficient for this one would actually be undefined, or you could consider it infinite. So it would be undefined, and but a slang way of thinking it would be you would have infinite elasticity. Not a very good example here. So unit elastic, though, this is the one. If you recall, when you're unit elastic, you're going to have a coefficient of 1. So it's these two right here that we focus on. It's what's going on here when we're relatively inelastic, and what do we do if we're relatively elastic. So these are the two where we have a coefficient. Well, if you just memorize these, if you're between 0 and 1, you are relatively inelastic. Your elasticity coefficient is going to be less than 1, but it's going to be greater than 0. If you're relatively elastic, your elasticity is just going to be greater than 1. And less than infinity, obviously. But that's something sometimes you memorize. Now, if you don't have it memorized, another way of calculating is with the total revenue test, which we'll do in just a little bit. But just to review elasticity, if you are very sensitive to price, okay, very sensitive, that's going to be over here, okay, very sensitive. And actually, let's do an example of that one. Very sensitive to price, I'm going to just draw that down here. We oftentimes use, let's say, entertainment, okay? And so of all your options, or we could do something like searches. So everybody uses Google, but there are a couple other options like Bing and MSN Search or DuckDuckGo or whatever you'd want. And so what would happen if all of a sudden there was Google started charging for a price, charge to a search? Well, just a tiny little price. What if they just said, we're going to charge you 5 cents a search, or even a penny a search? And so you'd say, well, normally on a given day, since I'm used to it being free, here is how many searches I have. This would be your quantity. And then they raise the price, and they just say, you know, we're going to start charging a penny. Well, because this thing is so flat, look at how a tiny change in price greatly affected the quantity. A very small amount here, a very small rise in price, resulted in a dramatic change in quantity. This tells me you are super price sensitive. And so there's lots of things that would feed into something being price sensitive. Sometimes it depends upon the amount of time involved. It depends whether the good's a necessity versus a luxury. If you were used to it being cheap or free, and now it costs something. So a small change here. So when this is very, very small, a small change really affects your behavior here. That is elastic. Whereas on the flip side up here, this was a really big change in price, but you had a small, or in this case, no change in your behavior. So the classic example for inelastic is usually gasoline. Gasoline's a good example. We'll sneak that graph in right here. So for gasoline, when the price goes up, you might change your behavior, but not by too much. And so there's how much gas you normally buy at this price, and then prices go up like $2. I mean, currently in our we're dealing with low gas prices, but let's just say the price goes up just a little bit, or goes up dramatically. We'll say even like $1. And so here's our new price right here. So here's piece of 2, piece of 1. And you can see when we have a really inelastic demand, we did buy a little bit less, but we didn't buy very much less. So big change in price resulted in a small change in behavior. We're pretty inelastic. We're insensitive to it, so we buy it anyway. Okay, it's just a brief review. Also works the same way for supply. So what we're being asked is to calculate the price elasticity of demand. So we're going to use this formula here. So let's get this out of the way. And let's see if we can actually calculate this now. So using our formulas here, let's see what's going on in this graph. So the coordinates, I think we have room to deal with this over here. So what we have is at $20, we have a quantity of 20. So I'm actually going to put a colon here. Okay, so at $20 we buy 20, and then the change is dropped to $12. So if we read the graph and we're doing demand at $12, this went to 24. So when it dropped to $12, we bought more, which is not surprising. Lower prices, you'll buy more. It's the law of demand. Higher prices, you'll buy less. But we're going to see by how much. So we're going to see if this is an elastic or inelastic good. So we're going to use our price elasticity of demand formula over here. So let's do our fraction over our fraction here. So I'll just write price elasticity of demand is equal to. Okay, so remember, price goes on the bottom here. So let's deal with the price. We'll do our denominator. Okay, so the difference in our price, we went from $20 down to 12, and this is absolute value in the midpoint method. But 20 minus 12 is going to be 8. We have that, and then the average of 20 and 12, that's going to be 32. The average of we're going to divide by 2, so we're going to get 16. Okay. So then let's look up here. We are looking at our quantity. So our quantity, we had 20, but we increased to 4. So our difference there is 4. And then the average of these two, the average of 20 and 24 is going to be 44. Okay, so all we have to do is simplify this little fraction. So this reduces to, I think we get 2/11, and then over here we get 1/2. Okay, and so we're going to flip that up, and we are going to get absolute value. I think we're going to get 4/11. Okay, so 4/11 is less than 1. So therefore, our conclusion would be this is relatively inelastic. Okay. But just to review it, I also want to go over the total revenue test. Okay, so I'm going to just draw that up here. The total revenue test, if you remember, the best way to look at it is what happened as you raised prices. So I'm just going to put a coordinate here at 2020. If you remember the total revenue test. So at $20, 20 times 20 is $400 was made. And at $12, so I'm going to lower that one to here. So that was 24 according to our graph here. So I'm going to bring this over here and say that was 12. Okay, so when we multiply $12 times 24, I believe we wind up getting 288. So 288 is the amount, but it includes this entire rectangle here. So what you want to look at is what happened when the price is higher. Now I know this problem says you lowered the price, but it doesn't matter. If at $12 you made 288, you raised it to 20 and you made 400. If you raise the price and you keep making money, that tells you that by the total revenue test that it is inelastic, relatively inelastic demand. Okay, so calculate the price elasticity of demand. We did here and show your work. By the way, when you guys are doing these, whenever an elasticity question comes up, make sure that you realize there's more than one way to calculate elasticity, and so sometimes you'll see more than one answer, or they'll give you the other method, which it'll be a decimal or a fraction they're going to be close, but there's a little bit of discrepancy depending on how you've been taught to do it. So the midpoint method, like I said here, we have 4/11. Actually, if you did it the other way, you wind up another way, which I don't teach you, is you'd get -1/2, but don't worry about that. All right, so then our last question is this in this price range, is demand perfectly inelastic? Or I guess that was the second part of the question. So this is 1 and 2. So there was our coefficient and there was our conclusion, because we were less than 1. Okay, so kind of incorporates a lot of issues, a lot of topics from earlier in the year, and but fairly straightforward. Okay, so that was question 3. So we had the 3 questions from Micro, old FRQ from the year 2015. All right, thanks for watching. We will see you guys next time.